Sequential search. So we are starting with searching algorithms. So searching for a data in fundamental computer programming task that has been studied for so many years. So this chapter looks at just one aspect. So first comes is the sequential search, that is searching for a specified value in the given list. There are two ways to search for an element. So first pattern is the sequential search and the other one is the binary search. A sequential search is used when the items in a list are in random order. Whereas a binary search, as I mentioned over here, sequential search is a pattern which are used whenever you get a list in random order, which is also called as the linear search. And whereas binary search is the other scenario where you also have to take into account the extra time it takes to sort the data set before being able to search it for a value. Sequential search is considered to be the most obvious way to search for a data in the given list, say beginning at the first element and then move on to each element of the list until you get whatever the value you want to find, you're looking for, or you reach the end of the list. This is a sequential search, and the best example of the sequential search is the brute force attack. Brute force search technique where potentially every element in the data structure is visited on the way to a solution. A sequential search or a linear search is very easy to implement. Simply start a loop at the beginning of the list, compare each and every element to the data you're searching for. If you find the particular match, then your search is over. But on the other hand, you don't get the required match, or if you get to the end of the list without generating the match which is needed, then the data to be searched for in the list is not there in the list. So you get the searching algorithm failure in that case. So let's go to our code base and first of all create a JS file. That is a JavaScript file, the implementation of a sequential search or the linear search in it, where we will create a JavaScript file with the functions associated to sequential search, and later on we will create whatever the HTML files which are needed for linear search or sequential search. So let's move on to our code base. So this is our code base, and here we have a searching algorithm. Over there we'll create a first file, say linear search, which is also called as the sequential search.html. So first thing I'll create a doc type. So it will be doc type HTML. Then comes my HTML tag. So that is HTML. Inside this I'll specify the head tag and the title tag. The title tag will have linear search or sequential search implementation. After this I'll specify, it is also important to specify the meta tag. So I'll say meta charset as UTF-8. Now I'll start with my body tag. Inside this I'll specify H2 illustration for sequential search in JavaScript. Now after this I'll specify the script tag. So that would be script type text JavaScript, and after that I'll specify the type is text as JavaScript and the source is linear search.js. So we'll create this new file and the name of the file will be linear search.js. So I'll create it over here in searching algorithm as linear search.js. So here I'm going to implement my logic for sequential search. So first thing is I'm going to generate the random array. For that I'll say function disperse array, taking array as the parameter. Inside this I'll say for I, variable I, equals 0, I less than array dot length I plus plus. And inside this I'll specify console.log variable I plus the blank value. Then I'll specify if I modulus 10 equals 9, then I will print a new line. This is just for a reference that if it follows, like every line should have 10 elements in it. So that is why I'm checking if whenever I get variable I with respect to 10, which is equal to 9, then I will print a new line. This is the first condition. And if I modulus 10 is even not divisible by 10, it is like every line I'll have only 9 elements in it. Then console.log new line. So I created with the disperse array or the dispersing of an array functionality. The next functionality comes is to call for the sequential search or the linear search. So I'll say function sequential search. First of all, I'll create a function and then I'll explain the logic behind it. It will take two parameters, array and data. Then we'll implement the logic for function. So here I'll say for variable I equals 0, I less than array dot length I plus plus. And here I'll specify if array of I is equal to data which is found, then I get the value return as true, which means if I get the match, so I'll just mention over here the proper comment for it. If I get, or if the appropriate match is found, then in such a scenario it will return the value as true. Now I'll create a number. So my number is say 101. And I just want to check if the number is existing in my particular array or not. First of all, it will create a random elements in the array. So in that random elements, if I get 101 match in it, then I'll get the console as my number is there in the array, which is a pattern which is followed for a linear search or a sequential search. On the other hand, if the number is not there in an array, then it will print that the number was not found in the particular array or the element was not existing in the array. So I'll say if, I'll call for if condition, sequential search, which takes two parameters, nums and num. So that is array and data. So my nums would be the one which is generated over here. If I get the value as true, then I'll say console.log num concatenated with a string is in the array, and I'll just mention it with a semicolon, and after that I'll say else console.log num is not present in the array. So this was my sequential search marking. Now what I'll do, I'll go to my browser, I'll call for linear search.html and just check whether I'm getting the appropriate output or not. Prior to that, it is important to create this nums value because we have called for disperse array. So here I'll just mention variable nums equals blank array, and here I'll say for variable I equals 0, I less than 100, I plus plus. In such a scenario, nums of I will be mat.floor mat.random into 101. So it is like I'm generating a number still the product of 101. So once this is done, then I'll say disperse array with nums. So this is actually used, so the functionality is used to print random arrays or random elements in an array. That would be very specific. Random elements in an array. So I've done with this functionality. Now I'll check in my browser and we'll have a look like what is the output we are getting. So this comprises of my searching algorithm, and here I'll call for linear search. Then in the console, I get a values like this. A random values, say 67, 26, 28, 92 and so on. And it reaches till the point where it reaches, and then I get that 101 is not present in my particular array. So I'll go to my code and just change the value, say some other value, for example 77. So I'll try till I reach a particular time where my element is present in the array. So now I get 77 is there in the array. If you just check out in my console, you get n number of elements which are present in it, and the 77 value is present over here. So that is why I'm getting the if condition to be set to be true, because 77 is being created from the random values of the array, and once I call for sequential search function that whether this element is there in an array or not. So basically sequential search is nothing but a kind of a linear search where you are checking each and every element, and if the match is found, it returns the value as true. So let's move on to the next chapter for understanding what is the next type of the searching algorithm typically in data structure, called as the binary search.